Welcome to Engineering Funda family. This video is a part of Network Theory lecture series, and in this video I'll be going to explain you two very interesting examples based on equivalent impedance calculation, and in that we'll be using Laplace transformation. So let us see the first question here. So if you observe, we have been given with this circuit, and for this circuit we are dealing with to find equivalent impedance Z of S, right, for this network. Now see, when you want to calculate equivalent impedance Z of S, you will have to replace all the elements in terms of Laplace domain, right. So let me redraw this circuit. After that I'll explain you how to substitute Laplace equivalent of these elements. So now see, I have redrawn this circuit, and in this circuit now see, we have capacitor and resistors. When you convert equivalent circuit in terms of resistors, for Laplace transformation it will be constant. So this 2, 1/3 and 1 ohm, that will not change. So Laplace equivalent is 2, 1/3 and 1 for resistor, it will not change. But when it comes to capacitor, then impedance of capacitor, that is 1/SC. So for half capacitance, it will be, this 2 will go in numerator by S, that is what equivalent capacitance impedance of this capacitor, right. For 1 Faraday, it is as per 1/SC, it will be 1/S. So that is how now we are having equivalent circuit based on Laplace equivalent circuit, right. Now we need to identify Z of S. So if you want to identify Z of S, then you can clearly observe here, see, this part is in series with this part, and that is in series with this part. Let us say this is Z1, let us say this is Z2, and let us say this is Z3, right. So what is ZS? ZS, that is series combination of Z1, Z2 and Z3, means Z1 plus Z2 plus Z3. Now what is Z1? So that is 2 parallel 2/S. Let me write that first, 2 parallel 2/S. What is Z2? So that is 1/3 parallel 1/S. So that Z2 is 1/3 parallel 1/S. And what is Z3? That is 1. So now we just need to solve this equation to get the value of Z of S. So in parallel it will be 2 into 2/S divided by 2 plus 2/S plus 1/3 parallel 1/S, that is 1/3 into 1/S divided by 1/3 plus 1/S plus 1. Now let us take LCM. So before you take LCM here, you see 2 will get cancelled and LCM is S over here, right. So this S and this S will get cancelled and 1, 2 will get cancelled. So in numerator there will be 2, in denominator there will be S plus 1, right. S2 will get cancelled, plus now see here LCM is 3 and S. So this 3 and S will get cancelled. So that will be 1 divided by S plus 3 plus 1. Now again we will take LCM of S plus 1, S plus 3. So here there will be 2 into S plus 3 plus 1 into S plus 1 plus 1 into S plus 1, S plus 3 divided by S plus 1, S plus 3. So let us solve this. So 2S plus S, and here there will be 4S. So 2S plus S plus 4S, that will be 7S. So let me write plus 7S. Now see here 2 into 3 6 plus 1 plus 1 into 3. So that will be 6 plus 1 plus 3, that will be 10. So plus 10 that I am writing. And you see here s into s square. So s square that I am writing. Right. Now in denominator we are having s plus 1 s plus 3. So that is s square plus 4s plus 3. You may be given with this answer, or you see 7s is there, so 5 into 2, right, that is how two fractions will be there. So this answer may be there in this way, s plus 2 s plus 5, this divided by, this is s plus 1 s plus 3, as 3 can be divided into 3 and 1, so that will make it to 4, right. So this is how we can identify z of s. Let me give you one more interesting question, so that will resolve your understanding. Now this question was there in GATE 2011. Here we are deal with to find current I of t. So this current that we are deal with to find. Now see here voltage source is given. So if I say here we are having this type of circuit, you see we are having one voltage source, we are deal with to find current, and if I say here I am having impedance Z, right, so I can say that I that is equals to V by Z. So V is given. So what is Z? Z is equivalent impedance of this much circuit. So technically our question is to identify equivalent impedance of this much circuit. Now whenever you have bridge type of connection, so here bridge type of connection is there. So we need to check out for balance, but you see here we are having capacitor and here we are having inductor. So for capacitance impedance is minus J4 and here it is plus J4. So we cannot balance this bridge, as this element divided by this element, that will be minus 1, that should be equals to this element divided by this element. So minus 1 cannot be equals to plus 1, means this is not there in balance condition. So how to identify equivalent impedance of this? So for that, if you convert this delta into star, then you can be able to convert given circuit. You see here I am connecting equivalent star connection of given delta, right. So let me redraw this much part of impedance over here. So now we will find the value of this star resistance. Now see here all the resistance are of 6 ohm in delta, so I just need to find one resistance only, right. So what is this resistance? This resistance is multiplication of side resistance, so that is 6 into 6 divided by algebraic sum of all three resistance. Similarly this resistance is multiplication of these two resistance divided by algebraic sum of all three resistance. But as all the values are same, you just need to find one resistor only. So the value of this resistance is multiplication of 6 and 6 divided by algebraic sum of 6 plus 6 plus 6. So that is 36 by 18 means 2 ohm. So I can say these three resistors that is are of 2 ohm, right. Now see we want to find Z of S over here, right, or you can say only Z. Here I am not converting that in terms of Laplace, as it is given in terms of values, right. So see if you see this Z, that is this wing parallel this wing. So this wing is 2 minus J4, so 2 minus J4 in parallel with 2 plus J4, right, and this is what they are in series with this, so plus 2 that I need to write over here. So that is how we have equivalent impedance of this much part of circuit, right. Now parallel means what? 2 minus J4 into 2 plus J4 divided by 2 minus J4 plus 2 plus J4 plus 2. Now see in numerator 2 minus J4, into 2 plus j4. So that is 2 square minus j square 4 square divided by this plus j4 and minus j4 will get cancelled, divided by 4 plus 2. So see, this is 2 square minus j square is minus 1 into minus 1 will be plus. So 4 plus 16 divided by 4. So 20 by 4, that is 5 plus 2. So that will be 7 ohm. So now we got the value of Z, that is 7 ohm. Now as you see, current I is V by Z. So V is how much? That is 14 angle 0. So 14 angle 0 divided by Z, that is 7, and there is no angle as no imaginary part is there, so angle is 0. So 14 by 7, that is 2 ampere, right, with angle 0. So you see 2 with angle 0, that is the correct option. I hope you have understood this. Still, if you have any confusion, just place that in comment box. I'll be happy to help you. Thank you so much for watching this video.